Alright, now we're going to look at a factoring a polynomial. Symbolically, remember that means algebraically, so using synthetic division. Alright, so I want to factor this polynomial. All I know is 1, 0. Alright, I know it has 1, 0 at -1. And actually, this one's hard to do graphically, because if you look at it graphically, it looks like it only has 2 zeros, but it actually has 3. And so you miss one of them if you're looking at it graphically. And so this one actually almost needs to be done synthetically. So this is where we're going to practice what we did before. Alright, so remember, this means that if it's a 0 at 1, that means x plus 1 was a factor. And I'm going to divide it out, which when I divide it out, I should get a remainder of 0, and it'll put it in factored form. And so I'm going to divide this using synthetic division. So my k is -1. Alright, so -1. 3, 2, 1, 0, so I don't have any placeholders, so it's 2, -2, -34, -30. I already know that the remainder should come out 0, so I know that, so going in, when I do my synthetic division, sort of my check. If I don't get 0 out as a remainder, I've messed up my synthetic division. Alright, so drop the 2, -1 times 2 will give me another -2, so I get -4, -1 times -4 gives me out a +4. That gives me out -30. -1 times -30 comes out +30, and I did get a 0 where I want to. Alright, so now we use that property that we learned in the last section, where it's the quotient times the factor plus the remainder. In this case, the remainder is 0. So remember, this is my quotient. It's 1 degree less, so this is going to be 2x squared minus a 4x minus a 30, and then it's times the factor x plus 1. It would technically be plus the remainder, but since the remainder is 0, I don't have to worry. And so I've factored it. Now, it's not completely factored, but now it's put it, right? Factoring cubes is hard. Factoring quadratics, though, we did a whole section, right? Chapter 3 was about factoring and simplifying quadratics. And so by doing this, by dividing out the x plus 1 factor that I knew, I've now got a quadratic which I can factor. First of all, I know I can pull a 2 out, so my leading coefficient's 2, right? I can divide a 2 out. It doesn't go anywhere, it just comes out the front. So I'll pull 2 out. When I pull 2 out, I'm going to be left with x squared minus 2x minus 15, and I still have the x plus 1 at the end. Then, to factor completely, that quadratic can be factored into 2 binomials, right? And so I'm just going to use the guess check method. If you want to use a box method or one of the other methods that we learned in chapter 3, you can, right? Math builds on itself. And so my guess check method is, I know that this is just x because x squared splits only into x times x. Factors of -15. So what do I multiply to get -15? When I add them up, I get a -2. Alright, well, -5 and +3, right? When I take -5 times 3, I get -15. When I take -5 plus 3, I get a -2. And there is my function completely factored. If you checked its graph, it would have 0, so it's got zeros at x equals 5, -1, and -3. And what's hard on the graph is actually to see the -1, -3, because they're actually squeezed tightly in together. It barely goes over, but you can graph it and check it. If you graph this, that's where it should cross the x-axis. And so you could go look at this again graphically. Alright, so that's an example of using synthetic division, and then we had to go one step further and factor using our quadratic case, because it got down to a quadratic, so that's one way we can use synthetic division. Alright, so there's an example of factoring using synthetic division. We'll stop there. The next thing we're going to talk about is multiplicity.